each line or segment. So in that picture, line AB is called a what?
Segment.
No.
No.
So like an angle of bicep.
Do you guys?
Central.
No.
Sediment.
It does start with an S.
Oh, I remember.
It's called a
Sally.
secant.
Secant.
Oh wait, I'll take it.
Secant.
Secant.
Emily's not alive.
Hurry, write it down. Let's go.
Secant.
Secant. This is 1A.
I can spell words.
Tuesday.
I can spell it. Yeah.
It's Monday.
SECANT. Yeah.
Is it Tesla product?
Okay, B, Tuesday. Line DE is a what?
Tangent.
Tangent.
Oh, that's like an A-B.
If it barely touches the circle at one point, it's called tangent. You all should know C. Segment BC is called a what? Radius.
Or radii.
Radii is for more than one.
That's a little bad.
Can't spell it, Mr. Jordan.
Okay, D. Segment AD is a what?
Circumference.
No.
Wait, A-B.
Diameter.
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 I didn't look at it. I just guessed.
Semicircle.
It's not arc AD, it's segment AD.
Wait, Mr. Burr, how do you spell radius?
Rad IUS. Okay, A segment AB is a what? Segment.
Minor.
Segment AB is a. I'm looking at 1E.
Chord.
It's called a chord. If it was an arc, they would put the arc symbol.
Obviously.
Okay. Number 3. The measurement of angle ADE. You guys see angle ADE in the picture?
Yeah.
Yes.
90 degrees.
Right. Emily just lied. And when a radius hits the tangent at the point of tangency, what angle is created? What kind of? A right angle. So it's not, number 3A is 90 degrees. It looks 90. It always is 90. When the radius hits the tangent line at the point of tangency, it's 90 degrees. Okay, B says angle BCD. Angle BCD is a central angle. So what do we know about central angles and the arc they intercept?
It's gonna be half of that.
No,
It is the.
Or is it the same?
it's the same. So it's 64 degrees. Okay, C is angle DAB.
So that's half of 64.
That is, you guys remember what that angle's called? What kind of angle is that? Inscribed.
I was gonna say that. but I was like,
Yeah, Emily, just hush. Inscribed angles are equal to half of their arc. So what is C then?
31.
30,
Good job. Thank you so much.
32.
Good job.
Thank you so much.
I looked at her page. I'm gonna start writing stupid
So
stuff.
after you get it wrong, you blame Whitley, basically.
Yeah. I'm gonna start writing stupid things on my paper.
Okay, number 5. So you guys remember this picture on 5 through 9? If the chords are, if a radius is perpendicular to the chord, it splits it in half. Okay, that was one thing. If the chords are the same distance from the center, the chords have to be the same length. You guys recall that?
Yeah.
So if PM and PN are equal, FH and JL are equal.
Uh-huh.
Okay, and they tell us in the directions PM is equal to PN, so yeah, there's gotta be the same. Okay, the other thing, kind of the main trick on this will be like one of the tricky questions on the test. If they ask for a radius, which radius can we find? How do we find a radius? Well, here's how we normally did it. Since this is a 90-degree angle, if I draw this radius in right here, it creates a right triangle and we just use Pythagorean theorem. And this radius should be the same as any other radius. Okay, so that's the trick. The line that they did not draw in, if we draw one in ourselves, make it a radius, use Pythagorean theorem to find it. Okay, anyway, that was what we learned on this lesson. Number 5 says FH is 30. So what is HN?
15.
15, yeah, because it goes halfway across, right? So there's 2 questions though. So it's 15 and JL, how long, if FH is 30, JL is what? 30. Okay, number 7, JL is 32 and PN is 12. Okay, this one's PN right there. This whole thing is 32. So if this is 12, this one has to be 12, right?
Yeah.
And if this is 32, what's this one got to be? Half. So that'd be 16. Okay, the first question they ask is, what is PK have to be?
Radius.
Okay, PK is a radius. So how could we find a radius?
You do 12 squared plus 16.
Right, this is a radius also, the one they didn't
It's
draw.
20.
So 12 squared plus 16 squared equals the radius squared.
It's 20 spoiler alert.
Yeah, those add up to 400, and what's the square root of 4? What times what equals 400? 20. Okay.
Don't need to thank me.
Nobody was, Paxton. So PK, even though it's in a different spot right there, is a radius also, so it has to be 20 as well. Okay, but there is a second question on number 7, and that is MK. So MK is like right here. How could we find MK?
Well, you just
Subtract 12 or 20.
Right, the whole radius we just said was 20, and this part is 12. So this part is 20 minus 12, 8, yeah. Skipped a 9. Number 9. Find Fn if JL equals blah 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 and FH equals blah blah blah. What do we know about JL and FH?
blah blah blah.
Put your computer away.
The same.
It's not a game.
I don't care. It shouldn't be out for any reason. Okay, what do we know about JL and FH?
They're equal to each other.
Yes, they're the same segment. So all that stuff, x squared, all that stuff should be equal to each other. So x squared plus 8x minus 12 should equal. Okay, that reminds me. What if they weren't equal to each other, but one of them was twice as big?
You put that over here.
Okay, or like I remember we struggled with
You
this
said or, so
a couple
that's
weeks ago.
technically
Like, if this was the small one, if we did this one times 2, that should be equal to that one, right? Remember we had a heck of a struggle. I think it was the girls figuring out how to
right.
do it.
Okay, let's just start dropping names.
I'm sure some of the guys did too.
I definitely struggled with this. I don't know what we're going to do.
Okay, but they're just equal. Okay, so how do we solve this equation?
Is it plus 27?
Is it 27?
Yeah, sure.
Alright, how do we solve this equation?
Let's go, James.
2 a.m. That's so young.
Alright, so normally, when we have an x squared equation, it's called a quadratic equation. We move everything to one side and either factor or quadratic formula. However, if I try moving this to the other side, what's gonna happen? They just go away. So it really quickly becomes not a quadratic equation. So it's just 8x minus 12 equals negative 5x plus 27. So now what do we do?
Add 5x to those.
Get my x's on the same side.
Then add 12 to
Yeah, you got kind of a basic, you want to get x by itself. 39 divided by 13.
Good question.
3. 21.
Times 3, right?
Yeah.
Times 3 times 3.
3.
So it's 3.
Uh-huh.
Okay, was x what they wanted? No. They wanted Fn. So if you guys look at the picture, they told us FH equals blah blah blah. So how would we find Fn?
You could plug it into JL and then divide it by 2.
Right, or plug it into FH and divide it by 2. And that would be Fn, right?
Yeah.
So now it doesn't matter which one, no, because these two are equal, so they should work both ways. But if I plug in 3 there and there, let's say, that'd be 3 squared is 9, 5 times 3 is 15. 9 minus 15 is negative 6 plus 27 is 21. Okay, that's the entire chord, but they only asked for half the chord, so 21 divided by 2?
11. Oh.
10.5.
Wait.
Oh, okay.
20 divided by 2 is 10. 1 divided by 2 is 0.5 or 100. Okay,
Where are we going today?
number 11. The whole way. You don't believe?
If you quit yapping, we could get there.
Exactly.
Shut your mouth!
Why can't you guys be quiet and studious like Paxton?
Oh,
Exactly.
That's my
Thank
bad.
you.
That is my
Finally,
bad.
he sees the true
Paxton is the
potential in the
standard.
room.
Paxton is the standard. Okay. Number 11. So on 11 we have QR, the radius, hitting RS, the tangent. So what happens when the radius hits the tangent line?
Good question.
We talked about this already today.
It makes 90 degrees.
Makes 90-degree angle.
Yup.
So those are right triangles. So guess what they're going to usually have us do when we have a right triangle?
36.
Pythagorean theorem at some point. Some point they're going to ask for Pythagorean theorem. Number 11 is actually kind of a bit of a flashback because they ask us like what theorem can we prove that those two triangles are congruent to make the segments congruent. Let me draw this real quick. So what methods have we learned in the past to prove two triangles are congruent? Side, side, side.
Angle.
Yeah, anyway, yeah, all that stuff.
Side, angle, side.
So, what do I know is congruent in these two triangles?
Those two sides, or this side that's the same, the shared.
This-
Which side?
This
The one
side
in the middle.
the line.
Okay, the shared side.
Okay.
The.
What else is the same in these two?
The,
So we got side, right?
is the bottom because they're both radius?
Okay, the radii have to be the same, because radii are the same
And then
circle.
the 90 degrees.
Okay, 90, these are both 90. So what do I have?
Side, side,
Angles?
side.
Wait.
No, HL.
Okay, right, is side, side, angle one of them?
No.
No, it's,
HL.
in a right triangle, it's hypotenuse leg. So that's what they wanted on 11, just hypotenuse leg.
Not the
What
Okay.
did they want?
I'm worried that's you know.
So, if those two triangles are congruent, the point is these tangent segments that are created are always congruent. Like these two have to be congruent every time. Tangents that intersect, that meet to the same circle, create congruent segments. All right. 13. Shh.
On 10, does it want right triangle or like the,
Yeah. Yeah. What kind of triangle does it have to be? Okay. 13 is it's a doozy. So be thankful it's odd, I guess. So QR is X. That was this one. RS is 2x minus 4. And I think the other one was 2x plus 4, yeah. QS is 2x plus 4. So, how could we figure out what X is here?
A squared plus B squared equals C squared.
That's right.
No.
equals X.
Pythagorean theorem.
Wait, what would it be?
This squared
That
plus
would be
this squared equals that squared.
That.
Okay, so let's see what that looks like. So it's x squared plus
That squared.
2x minus 4 squared, whoops, equals
That squared.
2x plus 4.
That's a lot. That's a lot.
Okay, what do I do with 2x minus 4 squared? Okay, remember that square just means you take it times itself. So you do 2x minus 4 times 2x minus 4. So we're not just squaring 2x times 2x and minus 4 times minus. We're actually doing all of it times all of it. Every term times every term. So it's actually a what kind of problem?
Foil.
Foil.
No.
Foil.
Shut up, Dennis. I
You
hate foil.
said distribute it.
No,
not
you
even
can't.
distribute it.
It's circumscribed.
Is it like
I think you're going to go to English class, not math.
Can this
Go to Bible class. Well, she'll learn about that.
It's all the time.
Okay, so FOIL, let's do this real quick. Shh. So 2x times 2x is the first, right? Which is what? 4x squared. Outside is what? Negative 8x. Inside, negative 8x. If we do negative 8x, negative 8x, okay, it's minus 16x. Negative 8x minus 8x, negative 16. And then the last, negative 4 times negative 4, plus 16. Okay, the right side is almost identical to this thing, except for they make pluses. So it's almost the same. 2x times 2x, still 4x squared. What's going to change? The outside is now what? 8x inside, 8x. So that's 16, positive 16x this time. And positive 16. Okay, so earlier we had a quadratic equation, right? And what did I say we normally do on quadratic equations? Move it to one side and factor it. Okay, let's start right here though. I forgot my squares. What's x squared plus 4x squared? Let's do that. 5x squared. Yeah, write the whole thing over
Again?
again. Just
kidding?
because it's fun. Okay, and then,
Just kidding.
so we're going to move everything to one side. So how am I going to do that? I'm going to do it all once. I'm going to subtract all this stuff to get rid of it on the right side. Okay, what's 5x squared minus 4x squared? X squared. Negative 16x minus 16x.
Okay, slow down a bit.
16 minus 16. It's gone. And then all this is gone, so 0. Alright,
Whoa.
so I think a week or two ago we did a factoring problem kind of similar to this, but this one doesn't have 3 terms. Like, normally there's like a plus, something out here, and then we factor that 3-term factor. This only has two terms, so we can't do the 3-term factoring. We're gonna take stuff out. So what can I take out of both of these?
X.
X. And what's left, if I divide an x out of both of those, is x minus 32. So, what x values would make these factors equal 0? What x could I plug in that would make this 0? Okay.
No.
What x could I plug in right here that would make this factor equal 0?
32.
32. And if this is 0, then the whole thing's going to be 0, right? So x equals 32. Well, now if there's an x on the outside, what could make this all equal 0?
0.
0. Okay, now x stands for like the radius. I don't know if you guys remember that, but x is like a radius. So does 0 make sense for x to equal?
Oh yeah.
No.
No.
Because then the radius would have to be 0 and it wouldn't even be a circle.
So it's 32.
So we were just going to keep the 32.
Right.
Okay, is that the answer? They wanted the x?
No.
They always want more.
They always want more. What did they actually want? I think it was,
Radius.
I think they wanted this thing, like
Look at that.
this length.
Yeah, they did.
So we just need to put our 32 back in.
32 times 2 is 46.
You're always gonna
64. And then minus 4 is 60.
60, yeah, that's it.
No way, you said 62.
Then you realize we're still on 13.
I like how even though she keeps getting stuff wrong, she never stops trying.
We love your perseverance.
No, I meant that
Is she
side
trying
so
though,
good.
or is she just like saying stuff?
Hey, you're so good at persevering, you should keep track of it.
She usually just echoes whatever
That's funny.
Whitney.
I'll cover your shins to be dead. Yes.
Okay, we survived 13. Congratulations.
Should we stop? Yeah.
No. Okay, 14, I know it's an even, but let's talk about it a little bit. It says, how many common tangent lines do two different circles have if they're tangent in the following ways? Okay, externally tangent, A. What do externally tangent circles look like?
They look like
It's
a
like
circle
right
with
beside
a
each
line
other.
on top.
Yeah.
Or
They're like outside of each other, but they're tangent. Like like eyeballs. Well, it's not really a drawing, but the question is, how many common tangents do they have?
One.
2, 3,
one.
3.
Oh, it's one of
Oh.
Two.
2, 3, 4, 5.
these. 4, 5.
4, 5.
Okay, is this a common tangent?
Oh.
No.
So 3.
So 3. Okay, it's gotta be tangent to both circles at the same time. Shh. Okay. The second part of 14 is their common or their internally tangent circles. What do internally tangent circles look like?
They like cross each other.
Yeah, so
Well,
like, they're
one's inside, that's what internal means. So it looks more like that. So how many common tangents? That's the B question. How many common tangents does that have?
One.
Yep. So on 15, it says, make a sketch illustrating each possible case of the total number of common tangent lines for two circles that are not tangent to each other. So kind of the same question, just the circles aren't tangent. So what could it look like if the circles are not tangent?
They don't touch each other.
Okay, they're
that
just
far.
floating apart. So how many common tangents do we have?
1, 2.
2, 4, 5, 6.
1,
Oh.
2,
And then cross.
6.
diagonal, right? 3,
4.
4.
First guess, let's go.
Anything else?
No.
Oh, I got it wrong.
Okay, 4.
Do we have to draw the picture? too?
Yeah, it does say draw it.
I
But
hate
both
that.
of them?
We know, you're bad.
14, it didn't say we had to draw it, but 15 it did tell us to.
I ain't saying she gold, dude.
Okay, what else could two circles look like if they weren't tangent? besides just floating apart like that.
Like, kinda like.
Okay.
One inside it.
Could be overlapping.
Oh, yeah.
And what did you say? I think Lennox said it.
One inside, like a bullseye.
One could be inside the other without being tangent. Okay, so I think of a fried egg.
Let's go.
So would that be 0?
Yeah, do these have any common tangents?
No.
No, so this one's 0. How about these two?
2.
Yeah. That guy and that guy.
I thought we were.
What's that one?
Oh, there's more than one.
It's all 15.
Come on. I gotta expand this.
That's ridiculous. Ridiculous.
I'm not afraid to take a stand. Everybody, don't take my hand. Work this all together. There's a song. Huh?
You guys should join the play.
Everybody.
Except for Paxton.
Especially you, Paxton. No, especially Paxton.
Don't take my hand. Jaden's in the play.
I am. I'm one of the leads, baby.
Paxton, if you had to do a tryout song for the play, what would you use?
The
Right,
diary.
guys. Every night that I fall apart.
I literally said diary.
I need you more than
All right. Enough.
Right.
Okay,
Right.
so 16 through 18 is arc length and sector area, which was that worksheet
Oh,
that we did once upon a time,
Yeah.
turned in last week.
ban him.
So, what was the formula for arc length? Arc length was a fraction of the circumference. You guys remember that? So, what's the circumference?
2 pi r.
No. You're combining the.
Pi r squared.
Emma, you're not
Okay.
allowed to talk.
Okay, this is circumference. And then, so the arc length is just a fraction, remember this? It's just a fraction of the
over
circumference. So we multiply times what fraction of the circle we're actually using.
Yeah,
8 over 360. Okay, so this is we're gonna need this for these 3 questions. And sector area, we did that on the same worksheet. Was a fraction of the circle area. So what's the circle area formula?
2 pi r, or no, a pi r squared.
Pi r squared. That's the one that has a squared. Yeah. 8 over 360.
To the end of life.
Shh. Hush. Okay. On 17, it says, so they're actually giving us the arc length, and we got to work backwards to find the radius. It's kind of the opposite of 16. 16, you have to find the arc length. So I'm just going to use the arc length formula, right? We did a couple of these, I think. So it says, find the circle's radius and the area of the sector defined by a 20-degree arc. So if the arc is 20 degrees, that means the angle is 20 degrees also. I guess we just put it right there.
Yes.
And then it says the arc length is, I think they said 3 pi. But we don't know the radius. Okay, so I'm just going to plug the stuff they gave me into the arc length formula. So 2 times radius times pi times theta over 360. I know theta is
20.
20.
Over 100.
Okay, and that should equal the arc length, which is
3.
3 pi. Okay, so now we need some algebra skills. How do I solve this for r?
Basically, you're gonna.
I want to get rid of all this stuff over
You
just
get
r.
rid of pi.
Okay, if I divide by pi, what happens?
It takes away the other half.
It goes away.
Then you can divide that too.
Okay, we could divide by 2, and we could divide by,
360.
No, all this is multiplied, we could divide by 20 over 360. Okay, or we could do, what's 2 times 20 is 40 over 360, which is like 1/9. So we could just divide by 1/9, which is actually like multiplying by 9. So it's just, the radius is, anyway, any way you do it, like divide that, or whatever, you should still get 27. 27 what? 27 centimeters.
You know the answer?
That's one of them. They asked for 2 things. They asked for the radius, which is 27 centimeters, but then they asked for the sector area. So how do we find sector area?
Pi r squared.
Right there. Just plug our radius into the formula, and then we're good. So 27 squared times pi times 20 over 360. Okay, now, if I was doing it, I would not plug pi in, I would just put pi in the answer. But occasionally you do it both ways, but I would not plug pi in. So I just do 27 squared times 20 over 360. I think if I remember right, this is like 31 over 2 or 15 and a half or something.
On 16, what does it mean when it says in the sector's perimeter?
Oh, 81 over 2, huh?
On 16, what does it mean when like?
Yeah, they kind of snuck that one in there, and they did that on 18 too.
Can we just do arc length?
Okay, I tell you what, I'll do, well, it's, yeah, the sector's perimeter, I'll explain it, but then I'll let you do arc length, yes.
Okay.
Okay, we didn't finish this though. Did anybody plug this in the calculator?
I did, but then I accidentally.
Don't trust Jaden's calculator.
No, I actually got the nice one.
I don't know. We just do this every
Because
week.
it's because my calculator is dead. So
27 squared times
127.17.
put batteries in.
times 20.
That's not right.
127.17.
Oh, you plugged pi in, didn't you?
Oh yeah.
We're not.
Don't worry. It's 81 over 2.
Okay, but if you don't plug pi in the calculator, you do need to go back and put it in your answer. Okay, so anyway, yeah, we'll
Do we
take
put sector area or like, we just put
centimeters squared.
If we do the pi answer, do you want us to round to the 10th place? Yeah. Like where you.
Probably. Sometimes they tell you in the directions. I guess this one doesn't. But yeah, when they put the decimal, they round it to the 10th place. If they don't tell you where to round it, I don't really care. You kind of.
Are we done for the day?
No, I want to talk about what.
Perimeter and.
I want to talk about what Willie said on 16 and 18. So it said that instead of the arc length, it said find the perimeter of the sector. What do you think they mean by perimeter of the sector?
Like the triangle.
Like, perimeter just means distance around, right? So they're like all these together. So really that's just the arc length
And the radius.
plus 2 radii. Okay, but we didn't really do it's not really hard to find the radius. I think they just tell you the radius. The radius is 4 in number 16. So you just take your arc length and add 4 plus 4. Just add 8. Now, you know what? Now that I told you how to do it, yeah, let's go ahead and do that. So make sure you add 2 radii onto your arc length.
So then on the other one would be add 14.
Probably, yeah, yes.
And that's like separate from the arc. Yeah.
Okay. Yeah, you do arc length plus 2 radii to find the perimeter.
Okay.
All right.
Good shot.
All right, yeah, we will stop there.